All right, welcome. Today's lesson is 6.2, which is trigonometry of right triangles. Should sound familiar. I mean, you've been doing that since geometry. Our focus today is mainly extending what you've learned about the unit circle into right triangle situations. We'll have some applications, but really overall, today's lesson is a lot of stuff that should be very familiar to you from chapter 5, which is kind of nice. I have some identities here that I'm just reminding you about. This is nothing new, but if you didn't already write down the reciprocal identities and Pythagorean identities, you might want to jot those in your notes if you didn't print off the note sheet. Just nice to refer to when you're doing your homework so you don't have to flip back and try to find these unless you have them memorized already. So I will refer to these throughout the lesson. So we're going to start with just some basic evaluation. I'm going to refer to the unit circle. Again, kind of trying to go away from having to visualize a triangle. These would be non-calculator questions. So when you get into calculus, it will be assumed that you can evaluate these quickly and easily. So I'm going to approach it in that manner. So if it says sine of 4/3 pi minus cosine of 4/3 pi, the first thing you need to know is where 4/3 pi would be on your unit circle. So hopefully you've gotten comfortable with splitting your unit circle into different angles here. So if I know 1/3, 2/3, 3/3, 4/3 pi down here in the third quadrant, excuse me, the cosine and sine values are -1/2 and -√3/2. So filling that in, the sine of 4/3 pi is -√3/2. Then I'm going to subtract the cosine of 4/3 pi, which is -1/2. And of course, subtracting a negative, you're really adding. So to simplify that, and there's already a common denominator. So if you leave your answer in exact form, which will be what WebAssign will want from you, you can just write that as one fraction of -√3 plus 1 all over 2. And that's it. So again, really just quick refresher on stuff that you're already familiar with. One more, we'll do one in degrees. So you can see the question is asking you various sine and cosine degree measurements of 30 and 60 degrees. So if I go back to my unit circle, 30 degrees is pi over 6 and 60 degrees is pi over 3. So I can see their cosine and sine values are there, again, respectively. So the sine of 60 degrees, the sine is the square root of 3/2. The cosine of 30 degrees is also square root of 3/2. Then I'm going to subtract the product of the sine of 30. So the sine of 30 is 1/2 times the cosine of 60, and the cosine of 60 is also 1/2. So I have that all written out here. When you multiply, of course, the square roots cancel out, and you multiply 2 times 2, so I get 3/4. 1/2 times 1/2 is 1/4, and 3/4 minus 1/4 is 1/2. And that's it. So you'll do some just basic evaluations, making sure that you're comfortable with finding these angles on the unit circle. All right, up next, quick reminder. When you have an angle in standard position with a terminal side, if it's a unit circle question, x squared plus y squared equals radius squared, on a unit circle, your radius would be 1. The sine and cosine values are x and y. So your sine is y, your cosine is x. Then your reciprocal identities say that the cosecant is the reciprocal of sine. So if sine is y, cosecant is 1 over y. Secant is the reciprocal of cosine, so that's going to be 1 over x. Tangent is the ratio of sine over cosine, so that's going to be y over x. And cotangent is the reciprocal of tangent, so that's going to be x over y. So just again, nothing new to you here, just kind of reminding you about those identities that are in place. You will be using those identities to solve various triangles, and probably the first thing you notice about these triangles is the angles are in radians instead of degrees. It does not change how you solve a triangle, so please remind yourself when you're asked to solve a triangle, you're just finding all of the missing sides and all of the missing angles. So looking at this first example, you're given one angle is pi over 3. In parentheses, I put no calculator because you should be able to recognize that this is a special right triangle. Pi over 3 is 60 degrees. This is obviously 90 degrees. So by default, we know this is a 30, 60, 90. So if this pi over 3 is 60, then I know that my angle down in the corner here will be pi over 6, which is 30, right? So again, I have a 30, 60, 90 triangle. Now, if you go back to your knowledge of 30, 60, 90 triangles, you know the ratios opposite of your short or your small angle, 30, is your short side. Opposite of 60 is square root of 3, and opposite of your 90 is 2. So knowing that this original side was 10 and the ratio was set to be a ratio of 1 square root of 3, 2, well, I'm obviously just multiplying by 10 here. So if I multiply my 2 by 10 and my square root of 3 by 10, that will give me my side lengths. So 20, 10 root 3, and 10 would be my missing sides, and square root of 6, or pi divided by 6, would be my missing angle. Okay, then one where we can't necessarily just not pick up our calculator. Okay, so if you look at this triangle, you're given pi over 7 is one angle, 90 degrees, which is pi over 2. So to find the missing angle, you know that the three angles have to add up to 180, but in radians, that's pi. So if I take pi, which is 180 degrees, and I subtract the 90, pi over 2, and subtract the pi over 7, that should give me my third angle. So I added pi over 2 plus pi over 7, get a common denominator, then subtract pi minus 9/14 pi, and I get 5/14 pi. So there is my missing angle. Then to find x and y, the other two sides, you can set up any trig ratio that you want, really, because you know all of the angles. I just set up sine to find x. Or y, excuse me. So if I do sine of pi over 7, SOHCAHTOA tells me that sine is opposite 22 over hypotenuse y. Okay, now you want to make sure your calculator is in radian mode. So do check that and make sure you get the same answer as I do. So type in sine of pi over 7 in your calculator in radian mode. I multiplied the y over here, and then I divided the sine of pi over 7. Okay, and that's going to give you your y value. Then to find x, there's all the answers. But to find x, it's really the same exact thing. So I just use the same angle of pi over 7, and I use the tangent because tangent is opposite 22 over adjacent, which is x. And then I multiplied the x over and divided the sine of pi over 7 to the other side, dumped that into my calculator, still in radian mode, and I got x is 45.7, y I got to be 50.7, and then I talked about how to find the angle of 5/14 pi. So there you have an example of solving a triangle. No different than what you've done before, except you have to think in a different mode now, radians. All right, on to a couple application questions. Before I get into those questions, I just want to make sure when you see this verbiage, so if you see angle of elevation or angle of depression, here's a visual of what they are. Both of those, though, angles of elevation or depression, revolve around your line or revolve around the horizontal. So if you're standing right here looking straight ahead, this horizontal line of sight would be the angle that it forms to the object that you're looking up to. So if this is the object, then this angle of elevation is because I'm looking up. Angle of depression would be looking down. So if I'm looking down at an object, this angle with the horizontal is my angle of depression. So those are all defined there for you. Maybe the picture helps in case you've never heard that terminology. It wasn't heavily used probably in geometry, but it will be here. So for example, I'll give you a second to read this. From a point on the ground 700 feet from the base of a building, it is observed that the angle of elevation to the top of the building is 21 degrees. And the angle of elevation to the top of the flagpole that's on top of the building is 23 degrees. Find the height of the building and the length of the flagpole. Okay, so you want to find, I sketched a picture here, but that would be probably for some of you the biggest challenge. So I sketched a building and then put a flag on top of the building. Okay, and then I actually didn't put you, but you're standing down here looking to the top of the building or looking to the top of the flagpole. So from the point on the ground, you're 700 feet from the base of the building. Okay, so this would be 700 feet. the height of the building, I called X. We don't know that. But the angle of elevation, so here it is. Here's you. Here's your horizontal, the 700. Looking up to the top of the building creates that angle of elevation of 21 degrees. Okay, the angle of elevation to the top of the flagpole is 23 degrees. So if I highlight that, and this is going to overlap for a second, I'm going to pull out my blue triangle just a little bit here. Okay, you can see this 23 degrees is all the way top to the top of the flagpole, and the 21 degrees is just to the top of the building. Okay, everything else is the same, except for now this X is the building height, Y is the building and the flagpole height. So make sure you understand the picture, because I'm going to go on to the math, obviously. So you want to find the height of the building, we'll find X, and the length of the flagpole. So if I can figure out the whole length Y and subtract off the building, that's going to leave me with the flagpole. Okay, so with that approach, I'm going to come over here and I color coordinated. So my green stuff is the building. So I did the tangent of 21 degrees. Make sure your calculator is now back to degree mode. You really need to be conscientious of that if you haven't already recognized that. So tangent of 21 is opposite over adjacent. So opposite is X and adjacent is 700. All you need to do is multiply the 700 over. So 700 times tangent of 21, and I got 268.7 feet. That would be the height of my building. Okay, so that's this part of the question is answered. Then if I go and do the same thing with my blue triangle, that's going to get to find Y. If I set up actually I can just set up a tangent ratio again. So tangent of 23 is opposite Y over adjacent 700, and then multiply the 700 over, and I got 297.1 feet. Now that is the distance of the building and the flagpole. So if I take my blue minus my green, that's going to give me the height of the flagpole. Okay, so I didn't circle this, sorry, but the green is the height of the building, and this circled answer is your height of your flagpole. All right, one more application. A police helicopter is flying at an elevation of 2,800 feet, directly above a straight highway. Two motorists are driving cars on the highway on opposite sides of the helicopter, and the angle of depression to one car is 72 degrees, and to the other car is 51 degrees. How far apart are the cars? So maybe see if you can visualize this, because again, for some, that's the trickiest part. So pause the video, because I'm going to unveil my picture here. Pause the video and see if you can sketch this out first. All right, so I have the helicopter up here, and then I have car 1, car 2. It says they're on opposite sides, right? Angle of depression, remember, if the helicopter is here looking straight ahead, that's my red line, angle of depression is looking down to the car. So one of those is 72 degrees and the other is 51 degrees. So I have those sketched in. Now, if you recall from geometry, when you have two parallel lines, red line and this bottom black line, two parallel lines cut by a transversal, then opposite interior angles are congruent. So if this is 72, then this angle here is also 72. Likewise, if this is 51, opposite interior, this is also 51. Okay, so I want to make sure you understand that before I take this picture any further. Also, the helicopter is 2,800 feet above, right? So if I fill in this angle, I just wanted to make sure you understood opposite interior angles. And that would be for car number 1. Car number 2, same idea, right? Except for its alternate interior angles, 51. I called this distance Y, and then I called this distance X. So again, I try to color coordinate the red and the blue for the two different cars. So keep in mind the question's asking how far apart are the cars. So if I can figure out X and Y and add them together, that's going to give me how far apart those cars are. So starting with car 1, this little triangle here, they are both right triangles. I can use the 72 degrees and set up a tangent ratio with that again. So if I do tangent of 72 is opposite 2,800 over X. Okay, and then if you, I think you can solve this, make sure you're in degree mode still. I multiply the X over and divide the tangent over, and I got 909.8. feet. Do the same thing for car 2. Tangent of 51 is opposite 2800 over y. And then multiply the y over and divide the tangent of 51. And I got 2,267.4. And if you add both of those together, the red and the blue distance, you get how far apart those cars are in feet. I also converted it to miles if that makes more visual sense to you, but you don't have to do that. So again, really the big idea here is making sure that you can visualize the picture correctly, which sometimes is the challenge. Otherwise, it's just setting up trig ratios that you have been doing for quite a while. So that is the end of your lesson, and I hope you have a wonderful rest of your day.